Alright, in this video we're going to talk about 1.6 day 2 damped trigonometric functions. So if we have a product of two functions, they can be graphed by using the properties of the two individual functions. So when we're going to multiply a function by a trigonometric function, we're going to get something called a damped trigonometric function. So let's kind of take a look at one of these things and see what's going to happen. Consider the function f of x equals sine of x. F of x equals x times sine of x. So if we take this and do what we've been doing with it, we would set our bx minus c, or in this case just x, equal to 0 and equal to 2 pi, and we would solve, which is done. So we know that we're going to have 0 and 2 pi as the starting and ending points. Right between those is going to be pi, pi over 2, 3 pi over 2. And if we thought about our parent function, that's going to go 0, 1, 0, negative 1, 0. Then, if we had something like 3 sine of x, we would multiply these values by 3, and then we'd go ahead and graph it. But we don't have 3. We have an x. So what we're going to do is the exact same thing that we've been doing. We're going to take this x and multiply it by our y values. So we're going to get 0, x, 0, negative x, 0. So we got to think then, well, what do we mean by x? Well, that's just the line y equals x. And the line y equals negative x for the negative x. So when we go to graph this thing, we know we're going to have the point 0, 0. Then pi over 2 goes up to x. Pi goes to 0, 3 pi over 2 goes to negative x, and then 2 pi goes back to 0. Now, if we were going to do 2 full rotations, we can go from 2 pi to 0, and we would still go from 0 to positive x. We're going to follow this same pattern, right? To 0 to negative x back to 0. So our graph is going to look like sine of x, except it's going to be squished in between x and negative x. So our damped function is basically going to be graphing the trig function that we have here and kind of squeezing it in between the positive and negative of the function that we're multiplying it by. That x that we're multiplying it by is going to be called the damping factor. So let's look at one more, and then we'll call it quits on this video. So here we're going to be looking at x squared sine of 3x. So we want to take that same approach that we took earlier, and we want to say 3x equals 0. We want to say 3x equals 2 pi. Divide by 3, x equals 0, divide by 3, x equals 2 pi over 3. So we know we're starting at 0, we're ending at 2 pi over 3. Halfway in between 0 and 2 pi over 3 is pi over 3. We get a pi over 6 in between those ones, and we're going to get a pi over 2 right here. So our sine function originally goes 0, 1, 0, negative 1, 0. But if we're multiplying it by x squared, we're going to get 0, x squared, 0, negative x squared, 0. So a quick sketch, this isn't going to be exact, but a quick sketch of x squared and negative x squared. It looks something like this. Alright, we're just sketching. I know we should probably be finding x, y points, but we're just trying to get the general idea, the general shape here. So if we go to graph this thing, again, we're going to go from 0. And let's change, I forgot to change the scale here, so let's make this 2 pi over 3 and make this pi over 3. So the same thing over here, that's negative pi over 3, and this is negative 2 pi over 3. So we're going to go from 0, 0. And then when we get to pi over 6, we want to be up here. Then back to 0, and then down here, and then back to 0. And if we work from the left to the right again, it's going to start at 0, go all the way up to my function, back to 0, down to that function, And again, it's going to keep the same basic shape of sine, but it's going to be kind of smashed in between x squared and negative x squared. So that's going to do it in this video, and we'll see you in the next one.